Hello viewers, today we are sketching modulus functions. So let's get started. So let's say we have our first equation, which is question number 1. We have f of x, which is equal to the modulus of x. So to sketch the graph of this our function, what we do is we let whatever we have inside the modulus, we set it to 0. So get whatever we have inside the modulus, then we set it to 0 so that we know the vertex of this our graph that we have. So we have x inside, so we have to set it to 0. So when we set x to 0 now, we have to come up with the values of x so that they help us to find the values of y. Then from there now, we can sketch our graph. So start from a 0, then we just move 2 units backward. So from 0 we go to -1 and -2. Then also we do the same forward from the vertex, which is x equal to 0, we move to 1 and 2. So this is what we have here. Okay, so now after doing this, now we know that these are the values of x, then these are the values of y, or f of x to say. So what we'll do is we'll start with -2 here. We'll substitute where there is x, we'll substitute with a -2. So where there is x, we should put a -2. So we'll have f of x, which is equal to the modulus of -2. Then this will give us, we know that here when you have the modulus of a negative number, you get the absolute value. So here we get a +2. So here we have our point, which is +2. Then again we do the same when x is equal to -1. We need to do the same. So we have f of x, which is equal to the modulus of -1. So here we get the positive value, which is +1. So here we put a +1. Again we say x is equal to 0. So what is x again? We'll substitute with a 0. So we have f of x, which is equal to the modulus of 0. So here again we get a 0. So we have a 0 there. Then again, what is x now? We substitute with a 1. So we have f of x, which is equal to the modulus of 1. So still here, even if you have a positive, you still get the absolute value. You get a positive value, which is a 1. Then again, so now we have a 1. So again, we do the same. What is x? We substitute with a 2. Okay. So we have f of x, which is equal to the modulus of 2. So f of x will be equal to +2. That's what we have. So now, given these points, we can now sketch our graph. So this is our graph that we have. So now, once we do that, we just need to indicate the values of x that we have. So whenever it comes to indicating the values of x, you just need to indicate the values that you have on this our table. Okay, so this is just sketching that we are doing here. So we just indicate the values that we have. So for the values of x, we have -2. We are starting at -2 all the way up to +2. So here we indicate the values of x that we have. So we are starting from, that is -2. So I'll start, this is -1, then this is -2. Then also for the values of x, we know this is at 0, so 1. Here we have a 1, then here we have a +2. So do the same for the y values. When we look at our table, we only have positive values of y. So what we just do is we just indicate for the positive values of y. So here we have a 1, then here we have a +2. So now we need to plot our graph. So we have -2, +2. So just straight here where these lines, where these points are intersecting, so we have a point there. Then again -1, that is comma 1, so we know -1 is here, so we have to say -1 comma 1, which is somewhere there. So we have a point just there. Again we have 0 comma 0, which is right here, and again 1 comma 1, so our graph will start going up. 1 comma 1, then also 2 comma 2, we have a graph there. So once we do that, now we need to connect this our graph. So connecting this our graph, so we'll have, that's a V, okay, so we'll have a V. So this is our graph, so this one becomes our graph. So that's how we sketch the graph. So you make sure that you indicate the arrows to, so once you indicate the arrows, what you're trying to say is this graph, it continues going to where it goes to infinite. It continues just like that. That's what these arrows will indicate. And also you make sure you don't forget to indicate the vertex. So here we've seen that our vertex is 0 comma 0. So from what I said, for you to find the vertex, what you do, just get whatever you have inside the modulus, then you set it to 0. So here we have our vertex that is at 0 comma 0. So these are the things that you make sure you indicate. So that's how we sketch the graph of this our function that we have. Then our second question, let's say we have f of x, which is equal to, that is the modulus of x plus a 2. So let's see what happens to our graph when we add a positive 2 there. So let's see how our graph will be. So it's the same procedure that we do. So what we do is you just get what you have inside the modulus, then you set it to what? To 0. So what we have is x, so we set it to 0. So we can see that our vertex is at x equal to 0. That's where we're going to, that's where our graph will turn from. So from this point now, we need to make our table value. So we start from 0. So similar thing. So what you're going to do, from this our vertex x equal to 0, you move 2 units backwards, okay? So from 0 we move to -1 and -2. That's enough. Then again from the same vertex, which is 0, you move forward by 2 units again, so it will give us 1 and what? 2. So this is what we have. So this is our table value that we will have, okay? So remember, this is these are the values of x, then here we have the values of y. So after that, again we do the same, you test it to the original function so that you get the values of y. So say what is x, when we substitute with we start with a -2, so we have a -2 here, okay? So for x equal to -2, what would be the value of y, okay? So here we'll have y, which is equal to the modulus. What is x there, we substitute with a -2, then plus a 2. So we have y, which is equal to +2, because here you get the absolute value, which is +2, then you say plus a 2. So we have y, which is equal to +4. So here we have a +4. So again we do the same. So also need to say when x is equal to -1, what will be the value of y. So we have y, which is equal to the modulus, where there is x, you substitute with a -1 to the original function. So we put -1 here, then we say plus 2. So we have y, which is equal to the absolute value for -1, it will give us a +1, then plus a 2. So we have y, which is equal to 3. So here we have the value of y, which is equal to 3 when x equal to -1. Then at the vertex there, that is when x is equal to 0, the value of y becomes, we have y, which is equal to the modulus, while there is x, we substitute with a 0, then a plus 2. So we have y which is equal to the modulus of 0, we still get a 0, then plus a 2 here. So we have y which is equal to positive what? 2. So we have y equal to positive 2. Then again, we'll do the same. Where there is x, we put a 1. So let's see what we get. So we have the modulus. Where there is x, we put a 1, then plus 2. So this will give us the absolute value for 1, it will give us 1, then plus what? A 2. So this will give us the positive 3. So here we put a 3. Again, where there is x, we need to put a 2. So we have the modulus of 2, then plus a 2. This will give us 2 plus what? 2. Then this will give us what? A positive what? 4. So this is what we get. So now, that's the issue of now sketching the graph. So sketching the graph of this our function, let's see. So this is our graph that we have. So now we need to indicate our points now. So like what I indicated, what you do is you indicate the values that you have. So on our table value, these are the x values that we have. So meaning that here we'll have this is -1, then this is -2, then here we have 1, then this is a 2. So this is at 0. Then for the y values, we have 4, 3, 2, 3, 4. So that is for the y values. So this is at 1, then this is at 2, then this is at 3, then we have a 4 somewhere there. Okay, so now plotting the graph, we have -2, -4. So we have -2 here, then comma +4 to say. So we have a point there. Then we have -1, 3 here. So we have a point there. Then we have 0, 2. So this is where we have the vertex now. So our vertex would be at what? 0, 2. So from here our graph will turn here. So we have 1, 3 as our next point, and also finally we have what? 2, 4. So now we need to sketch our graph here. So our graph now is just a V, which will touch on all these points that we have. So from here it goes like that. So this becomes our graph. So like I said, you make sure that you indicate the vertex. So our vertex is at a point that is now at 0, 2. So that's where we have our vertex. So this one becomes our graph. So in a case where they ask you to find the domain, so what you're going to do to find the domain, we can see there is no any limitation. We don't have any asymptote here. So therefore, just say the domain will be -infinity to what? +infinity. Then now the range, this our graph we can see starting at 2. So at 2 it will be what? Closed. Then it's going to where? +infinity. So that one becomes the range. So that's how you sketch the graph. And also when you look at the way this our graph is, for the other one, when we had just the modulus of x, our graph started at 0, 0. So now since we have a shift, meaning that the y value our graph would be at 2. It will start at 2, then going to where? +infinity. And also whenever the coefficient here is positive, meaning that this our graph will open upward. But if the coefficient here is negative, the graph will always open what? Downward. So that's what you need to know. So let's also do the next question. So this will be our third question. So for our third question, let's say we have f of x, which is equal to that is the modulus of x, that is +3, then -3. So this is what we have. So to sketch the graph for this our modulus function, what we'll do is the same procedure will apply. So get whatever we have inside the modulus. So inside the modulus we have x plus what? 3. so we set it to 0 so that we know our vertex. So here we are getting x, which is equal to -3. So we have our vertex at x equal to negative what? 3. So now we need to make our table value. So remember, our vertex is -3. So we do the same procedure. So from -3, we need to move backward by 2 units. So from -3, we have that is -2 and negative what? 1. Okay, so these points are enough. Then again, that is from the vertex, we need to move forward by 2 units. So we have that is now, so here I've just made an error. So starting from our vertex, which is negative what? 3. So moving backward by 2 units, we get -4 and what? -5. Okay, then again from -3 we move forward by 2 units. So we have that is -2 and -1. So therefore we make these are the values of x that we use so that we get the values of y. So now we'll substitute what is x. When we substitute with a -5, what will be the value of y? So y will be the modulus. So what is x to this our function? You substitute with a -5. So we have -5 plus what? 3, then -3. So here we have y, which will give us -5 plus 3. This will give us that is -2, then -3. So we have y, which is equal to, so here you start with whatever you have inside the modulus. So what you do is you say the modulus of -2, you get the absolute value, which becomes +2, then here -3. So we have the value of y, which is -1. So here we have the value of y, which is -1. Again, we say x equal to -4. Let's see the value of y that we'll get. So we have y, which is equal to the modulus. Then what is x? We put -4, then +3 here, -3. So we have y, which is equal to the modulus of so let's deal with whatever we have inside here. So -4 plus 3, this will give us -1, then -3. So we have y, which is equal to the modulus of -1. We get the absolute value, which is +1, then -3. So here we have the value of y, which is equal to -2. Again, we need to do the same. So here we are indicating a -2. Okay, so again we do the same for x equal to -3. So for x equal to -3, we have y, which is equal to the modulus. What is x? We put a -3 plus what? 3. Remember, that's where we have the vertex. So -3. So we have y, which is equal to the -3 plus 3. That will be 0. Okay, then -3. So y will be 0 minus 3. So we have y, which is equal to -3. So here we have y, which is equal to -3. Again, what is x? We substitute with a -2. So we have y, which is equal to the modulus. What is x? We put a -2 plus what? 3. So here there's a -3. So we have y, which is equal to, here we get a 1, then -3. So y will be, the absolute value is still 1, then -3. So we get y, which is -2. So here we get a -2. Again, we do the same. What is x? We need to substitute with a -1. So we get the modulus. What is x? We put a -1, so +3, then -3. So now this will give us -1 plus 3. This will be 2 minus 3. Okay, so here there's a modulus, remember. So this will give us a 2 minus 3. So this will give us a -1. So here we have a -1. So now we need to sketch our graph using these our points that we have. So this is our graph. this is our graph. So here, let me just create some space here, remove this. Okay, so now we need to indicate the values that we have here. Okay, so we need to indicate the values that we have. So number one, we have x -5 all the way up to -1. So this is -1, then this is what, -2, then this is -3, then -4, then here we have a -5. So we can see that all these are points, they are on the negative sides. Okay, so since we know that they are on the negative side, what is guiding us, what will guide that these values will be on the negative side is this -3 that we have. So this will indicate that your graph now, it will shift to the what, to the left side. So your graph, it will be to the left side. So how will be this our graph now look like? Since here we have a positive, meaning this our graph will open upward. That's what it means, but it will be on the negative what side. So now for the y values, we have these are the values that we have. So negative values, so is we have, this is -1, this is -2, then this is -3. So now plotting, now we have -5, -1. So -5, -1, we have a point right here. Then -4, -2, so we have a point just here straight. And -3, -3. So here we have a point somewhere here. So this is where we have our vertex. Then now from here we move to -2, -2. So we have a point there, and -1, -1. So we have a point there. So meaning that our graph now, if we plot our graph, it will look like this. So still a V. So this is our graph. So our graph will go like this. It will cut at 0, 0 there. So this becomes our graph. We show the arrows to say this graph will continues moving like that. So basically that's how we sketch the graph of a modulus function. So that's how we sketch the graph for this. If they ask you to get a domain, just say the domain of this our function is always -infinity to what, +infinity. But now the range, you look at where the graph is starting. So the vertex is that is -3, -3. So just look at the y value. So our graph is starting at -3 to be closed, then it's going to where positive what, infinity. So that becomes the answer. So now let's see now when our graph now has a negative coefficient. So just an example, so if our fourth question is like f of x equal to, that is -2, then here we have the modulus of x, then plus what, a 1. Okay, so to sketch the graph for this our function, the procedure will be the same. So the way this our graph will be, since we have a negative this side, so this will indicate to us that this our graph will open downward. So this our graph will open downward. Okay, so since we know that it opened downward, so let's now get the values, the vertex to say. So to get the vertex, you get whatever you have inside the modulus. So you ignore the -2 there. So you just get what you have inside the modulus. So we have what, x. So we set x to what, 0. So since we know our vertex will be at 0 now, so say from this 0, we need to move backward by 2 units. So we have -1, and also that is negative what, -2 here. So this is x, and this side we have y. Then again, if from 0 we move forward by 2 units, so have 1 and what, 2. This is what we have. Okay, so from here now, we need to get the values of y. So we say when x is equal to -2 here, okay, what are we going to get? Okay, so we have y, which is equal to -2, then the modulus. So what is x? We need to substitute with a -2, then we say plus what? 1. So this will give us -2, then the modulus of -2, we get the absolute value, which is +2. So here we are multiplying, then plus 1. So this now will give us -2 times 2. This will give us -4 plus 1. So this will give us -3. So here we have a -3. Then again, when x is equal to -1, so what value are we going to get? Okay, so we have -2, then what is x? We need to put -1, then plus 1. So now we have -2 times the absolute value for -1 is +1, then plus 1. So this will give us -2 times 1. This will give us -2 plus 1. So this will give us -1. So here we have -1. So again, when x is 0, what value of y are we going to get? So when x is equal to 0, so we have -2, the modulus of, here we put a 0 plus 1. So we have -2, then the modulus of 0, this will give us a 0, then plus 1. So this will give us +1 here. Okay, then again, when x is equal to 1, so we have that is -2, then the modulus of, what is x? We put a 1, then plus 1. So this will be -2. Then here the modulus of 1, we get that, then plus that. So here we have -2 plus 1. So -2 plus 1, this will give us -1. So again, what is x? We substitute with a 2. Let's see the value of y that we get. So we have x, which is equal to 2. So we have -2, the modulus, what is x? We put a 2, then plus 1. So this will give us, that is -2 times the modulus of 2, that's 2, then plus 1. So this will give us -4 plus 1. So this will give us a -3. So now this is what we have. So now we need to sketch our graph. So we need to sketch our graph. Okay, so we need to indicate the values. So for the x, we have so that is -1, then here -2. Just indicate the values that you have on the table. Then again, so this is at 0. So again, from 0 we have that is 1 and what? 2. So for the y values, we have negative y values and +1. So this is +1, and also we have, this is -1, this is -2, then -3 will be here. So plotting these points, we have -2, -3. So we have a point here, then -1, -1. So okay, let me use a white marker. So here, so again we have -1, -1. So we have a point there, and 0, 1, that's where our vertex will be, and 1, -1, and 2, -3. So it will be v facing what? Downward. That's the modulus what? Function. So it will be v that is facing where? Downward. So what we will have is a v facing downward. So to cut at the vertex there, so that point I was supposed to move it there. Anyway, then also this is what we will have. Just indicate the arrows to show how the graph will look like. So that's what you do. So this becomes our graph. So the main reason why this our graph, it has first downward. The reason is simple. One, here the coefficient is negative, so that's why this our graph is facing where? Downward. That's what it is there. So that's what it is. So you just have to indicate a vertex. So our vertex is that is 0 comma what? Our vertex is at 0 comma 1. So let's try and state the domain. So the domain for this our function will be negative infinity to positive infinity. Okay, then the range, this our graph is starting at for the y value there that we have, this our graph is starting at 1, then going to where? Negative infinity. So this is what we have. So this becomes the graph. Then our fifth question, which is question number 5. Let's say we have y which is equal to negative 2, then here we have x minus 1, then here plus a 3. Okay, so let's see how our graph will look like. Since again here we have a negative here, meaning that this our graph will open downward. That's what we are going to have. So this our graph will open downward. So to get the vertex, you get whatever you have inside the modulus. So what we have is x minus 1. So we need to set this to 0. So we have x which is equal to 1. Okay, so that's where we have our vertex. So here we have x, here we have y. Okay, so from here now we know that x is positive 1. So from 1 we move 2 units backwards. So from 1 we move to 0 and negative 1 there. Then again, if from 1 you move 2 units forward, so we have 2 and what? 3. That's what we have. So now from here now you indicate these values. So for x equal to negative 1, what will be the value of y? Okay, so we'll have y which is equal to negative 2. Then the modulus, where there's x, we need to put negative 1, so minus 1, then plus what? 3. So we have y which is negative 2 here. The negative 1 minus 1, this will give us negative 2. Then we have plus what? 3. So we have y which is negative 2. Then the modulus of negative 2, just get the absolute value which is positive 2. Then plus what? A 3. So now this will give us negative 4 plus 3. This will give us negative 1. Here we have a negative 1. Again, where there's x, we need to substitute with a 0. So we have y which is negative 2. Then the modulus, where there's x is 0 minus 1, then plus what? 3. So here we have negative 2, then 0 minus 1, negative 1, then plus what? 3. So now this will give us, this is negative 2 times, then the modulus of negative 1, this will give us positive 1. We get the absolute value, then plus 3. So now this will be negative 2 times 1. This will give us negative 2 plus 3. So now this will give us what? Positive 1. So here we have a positive 1. So again we do the same. Where there's x, we put a 1. Okay, so we have negative 2, the modulus of where there's x, negative 1 minus 1, then plus what? 3. So now this will give us negative 2, then negative 1 minus 1, this will give us negative 2. So plus what? 3. So now this will give us negative 2 times, then the modulus of negative 2, this will give us positive 2. So plus 3. So now this will give us negative 2 times 2. This will give us negative what? 4 plus what? 3. Then here we have negative 4 plus 3. This will give us negative 1. So here we're getting negative 1. So again, what is x? We put a 2. Let's see what we get. So we have negative 2, the modulus, where there's x, negative. So we're putting a positive 2. Then we have minus 1 plus what? A 3. So we have negative 2, then 2 minus 1, we get a 1 plus what? 3. So we have negative 2. So the modulus of 1 will get a positive 1 plus what? 3. So now this will give us negative 2 plus what? 3. So this will give us 1. So here we have 1. Again, what is x? We substitute with a 3. Let's see what we get. So I have negative 2. Then here we have this is 3 minus 1, then plus 3. So now this will give us negative 2. Then 3 minus 1, this will give us a 2, then plus 3. Okay, so this will give us negative 4 here plus 3. This will give us negative 1. Okay, so here we have what? For x equal to 3, what we are getting is negative 1. So I think there's just an error when x is equal to 1. Let me just check. So for x equal to 1, for this, let's do again. So that's a positive, not a negative. So we have y, which is equal to negative 2. So we have 1 minus 1 here plus what? 3. So we have y, which is negative 2, then times this is 0 plus what? 3. So I have y, which is negative 2 times 0. This will give us negative, that will be 0 plus what? 3. So the value of y becomes a 3. So the value of y becomes what? Becomes a 3. That is when x is equal to what? 1, not negative 1. So here we have what? A 3. So that's what we have. So our vertex will be at 1, 3. So now let's sketch our graph. So to sketch our graph, what we will have is let me do this. Yeah, so this is our graph. Okay, so this is our graph that we have. So from this our graph, we need to indicate the values of x. So the values of x, we have, this is negative 1, this is at 0, this is 1, then here we have a 2, here we have a 3. So for the values of y again, so we have this is 1, then this is a 2, then here we know that this is a 3, then here we have a negative 1. So now we need to plot these our points. So we have negative 1 comma negative 1. So negative 1, that is comma negative 1, we have a point there. Then 0 comma 1, we have a point there. Okay, then we have 1 comma 3, so this is where our vertex will be. Then 2 comma 1, we have a point there. Then we have 3 comma negative 1, so we have a point there. So now we need to plot our graph. So plotting this graph, it will look like this. It's a V, remember? So it will be like this. So I'm supposed to move that point anywhere there. So I need to move this point, which is 0 comma 1. So in fact, let me just test and confirm this value. So for x equal to that is 0, let's see what we'll get. So for x equal to 0, let's see what we'll get. So for x equal to 0, I have negative 2 here. So 0 minus 1, then plus what? 3. So negative 2 here times 1 plus what? 3. So here we'll have negative 2 plus what? 3. So getting 1. So it's 0 comma 1. Okay, that's okay. We have that point. So now let's continue with our graph. So even here, this our graph will go like this. So that's how our graph will look like. Yeah, so if they ask for the domain and the range, what you do is we'll say the domain of this our function, okay, So the domain of this our function is negative infinity to positive what? Infinity. Then the range, this our graph is starting at the y value that we have is 3 from the vertex. So it will be 3 to where it's going to negative values. So to negative what? Infinite. So this one becomes the range for this our function. Then our sixth question that we have is y equals to negative 3, then the modulus of x plus what? That is 2, then minus 4. So here we need to sketch the graph. So the first thing we'll find the vertex. So we have x plus what? 2. So we need to set this to 0. So we have x which is equal to negative 2 here. So given this value, say from negative 2 we need to move backwards 2 units. So we have that is negative 3 and negative what? 4. So this is what we have. So this is x, then this is y. Then from negative 2 again we move backward by 2 units. So we have negative 1 and what? 0. So this is what we have. So again, we'll substitute. Where there is x, we substitute with a negative 4. So let's see what we'll get. Negative 3, then the modulus. So where there is x, we need to substitute with a negative 4 here. So negative 4 plus what? 2. So that's what we have. And here there's a minus 4. Remember, then after that, we have this is negative 3, then negative 4 plus 2. Negative 4 plus 2, this will give us negative 2, then minus 4. So now we have negative 3. We multiply this by the absolute value of negative 2. So this will be positive 2 minus 4. So this will give us negative 6 minus what? 4, which will give us negative 10. So here we have negative what? 10 as the value of y. Again, we do the same for x equal to negative 3. So for x equal to negative 3 here, what we have is negative 3, then the modulus, okay? That is where there is x, we need to substitute with a negative 3. So negative 3 plus what? 2, then minus 4. So now this will give us negative 3. Then where there is x, so here we've substituted already. So we say negative 3 plus 2, this will give us negative 1, then minus 4. So here we have negative 3, so negative 1, the absolute value for negative 1, we get a positive value, which is positive 1, then minus 4. So negative 3 times 1, this will give us negative 3 minus 4. This will give us negative what? 7. So here we are getting negative 7. So again, if we do the same, while there is x, we need to substitute with a negative what? Negative 2, okay? So while there is x, we need to substitute with a negative 2 this time around. So we have negative 3, then the modulus of, so this will give us negative 2 plus what? 2, then minus 4. So this will give us negative 3. Then times negative 2 plus 2, this will give us a 0, then minus 4. So this will give us, this is negative 3, then the absolute value for 0 is to get a 0 minus 4. So negative 3 times 0, this will give us 0, so minus 4, we have negative 4. So here we are getting a negative 4. So our vertex will be at negative 2, that is comma negative 4. Again, while there is x, we need to substitute with a negative 1. So we have negative 3, then the modulus, then this is negative 1 plus what? 2, then minus 4. So now this will give us negative 3, then negative 1 plus 2, this is 1, then minus what? 4. So negative 3 times the absolute value for 1, this will give us 1 minus 4. So negative 3 times 1, this will give us negative 3, then minus 4. So this will give us negative what? 7. So this will give us negative 7. Then again, where there is x, you substitute with 0. So we get negative 3 here, 0 plus what? A 2, then minus a 4. So this will give us negative 3, then 0 plus 2 will give us a 2, then minus 4. So now we have negative 3 times the absolute value for 2. This will give us a 2 minus 4. So here we have negative 6 minus what? 4. So this will give us negative 10. So here we have what? Negative 10. So now we need to sketch our graph. So I need to create some space here. Okay. Okay, you need to create some space. Okay. So now here we need to indicate the positive values of x. So indicating the positive values of x, we have that is negative 1. Then here we have negative 2, negative 3, and negative 4. Then here we have a 0. Then for the y values, these are negative values now. So now I need to move this graph. So let me just move it up. So let me do this. I need to move this up. Yeah, I need to move it up. Okay, better this way. Okay, perfect. So now once I move this graph up, so now I'm done moving it up. So let's now sketch. So for the values of x now, like I said, so we have this is negative 1, this is negative 2, this is negative 3, then this is negative 4, then this is what? 0. Then for the y values, we have negative 4. So negative 4 will be somewhere there. Okay. Then negative 7 will be somewhere there. And this will be negative 10. So this is what we will have. So now we need to sketch this our graph now. So we need to use these our points now. So let's see how our graph will be now. Okay. So let's see this how this our graph will be. So okay, so we have negative 4 comma negative 10. So the point will be somewhere there. Okay, then again we have negative 3, that is comma negative 7. So negative 3 comma negative so they have missed it. So I'm saying it's negative 4 comma negative 10, just somewhere there. Then negative 3 comma negative what 7, we have a point there. Then negative 2 comma negative 4, that's where we have our vertex right here. Then from this point now, our graph will start going down. So we have that is negative 1 comma negative 7. So we have a point there, and 0 comma what is 0 comma 10. So this is what we have. So now we need to connect these our points that we now have. So connecting these points, we get, so this is what we have. This is what we have. So that point I was supposed to move it somewhere there. Okay, so show the arrows to say this our graph, it continues like that. So this point I was supposed to put it there. So now you indicate the vertices, the vertex to say, I mean, for this our graph. So indicating the vertex, what we have is our vertex is at that is negative 2 comma negative what 4. So if you want to state a domain, you say the domain will be negative infinity to where positive infinity. Okay, then the range, that's where we have our so this is our graph starting from the y value, which is that is negative 4, going to where negative infinity. So that becomes the range. Then our last equation for today, which is question number 7, we have f of x, which is equal to, so this is 2, then the modulus of that is x plus 1, then minus 1. So now what we'll do here, we also need to know the vertex. So we'll get x plus 1 and set it to 0. So you get what you have inside the modulus and set it to where? To 0. That's what you do. Okay. So meaning that we have x which is equal to -1. That's what we have. So now from -1 we need to move that is 2 units backward. So when we move 2 units backward, let's see what we get. So this is -2, then this is -3. Okay, so when we move backward, then again from -1 we move forward by 2 units, we'll get that is 0 and what? 1. That's what we get here. So here we have x, here we have what? Y. This is what we have. Okay, so when x is -3, let's see the value of y that we get over the value for f of x. So we have this is 2, then the modulus, then we have x plus 1. So where is x, we need to put a -3, then plus 1, then minus 1. So this will give us that is 2, then -3 plus 1, this will be -2 minus 1. So this is 2, the -2, the modulus for -2, it will be the absolute value, which is +2 minus 1. So this will give us 2 times 2, that's 4 minus 1. This will give us a 3. So here we have a +3 when x is -2. So we have 2 open, the modulus, then what is x, you put a -2. So -2 plus 1, then minus 1. So we have 2, then -2 plus 1, this is -1, okay, minus 1. So this is 2, then the modulus of -1, you get the absolute value, which is +1 minus 1. So here 2 times 1, we get a 2 minus 1, this will give us a 1. So here we have a 1. Okay, then again we do the same when x is -1. So we have 2 here. What is x? We put a -1 plus 1, then minus 1. That's where we have our vertex. So here we have a 2, then -1 plus 1, this will give us a 0 minus 1. So here we have a 2 times the modulus of 0, we have a 0 minus 1. Okay, so 2 times 0, this will give us a 0 minus 1. So this will give us -1 there. So we have -1 here. So our vertex will be at -1, -1. Okay, then again when x is equal to 0, we do the same. So we have 2, what is x? We put a 0 plus 1, then minus 1. So this will be 2, then 0 plus 1 is 1, so minus 1. So 2 times the absolute value for 1 minus 1. So we have 2 times 1, which will give us a 2 minus 1. So we have a 1 there. So here we have a 1. Again, where there is x, we need to put a 1. Let's see what we get. 2, then 1 plus 1, then minus 1. So we have 2, then 1 plus 1, this will give us a 2 minus 1. So 2 times, then here we have 2 minus 1. So this will be 4 minus 1, which will give us a 3. So we have a 3. So now we need to sketch our graph. Okay. Okay, so given this our graph, we need to indicate the values of x. So we have that is 1 here, this is 0, then this is this is 1, then this is -1, then here we have -2, and here we have -3. So for the y values, we have here that's a -1, then here we have a 1. We know that 3 will be somewhere there. So now we need to plot these our points. So -3, that is comma 3. So we have a point there. Okay, so that's where -3, 3 is. The -2, 1, we have a point here. Then our vertex is at -1, -1, which is right here. Okay, then again 0, 1. So 0, 1 goes up, then 1, 1, so this our graph would be like this. So this is what we have. So for our vertices, we just need to indicate our vertices. So our vertices, we have -1, -1. So here the domain for this our graph still -infinity to +infinity. That's what it will cover. Okay, +infinity. Then the range that we have is so this our graph is starting at the x value, that's -1, so it's going to +infinity. So this is what we have.